Right, so we have designed a demonstration which is more based on a real-life application. It is using the features of the U0, so it's using its ultra-low power capabilities, and we're running the target board here. So we're bringing our target board here, and it's purely powered by a photovoltaic panel. So there's no battery in this target side. And what we have is a new technology from a company in France called Dracula Technologies. And they're using an inkjet printed organic photovoltaic layout. And it can work down as low as 5 lux. That's basically moonlight type levels of illumination. So what we have on the target board is we have the discovery board, which you will see in the next hands-on. On top of that, we have a sub-gigahertz RF Arduino board. So it's using our Spirit 2. And this is going to send information over to the receiving side, which is the standard Nucleo board with a graphical display and another Spirit 2 board on there. So we've got the data logging side on this side and also a visible display, and that is all transmitting that information across to our target board. So what we have here is, I'll skip this data logging only configuration. It's exactly the same as this one with the RF part. So what we have is the photovoltaic cell connected as if it's powering a battery. Then we have another pin here, which is what we're using to measure the lux levels coming from our photovoltaic cell. And then we have another feed here that's powering our RF side. And then this is going to transfer the information over the Spirit 2, so the sub-gigahertz RF link, to the receiving side, which is then going to graphically show it nicely on the display. So how does it work? When we switch the lights on, the photovoltaic will start charging our capacitor. That will eventually hit the power on reset threshold. At that point, the microcontroller wakes up. We do a bit of basic setup. So we set the programmable voltage detector to get to 3 volts, and then we drop straight into the stop 2 mode that Antoine's just shown you. We then wait for the device to reach the programmable voltage detector threshold, which is 3 volts. At that point, then we then initialize all the peripherals. So we initialize the LCD, the temperature sensor, and the RF module. Then we set the RTC to wake up the device at regular intervals. At that point, we then drop back into low power mode. So we go back into stop 2. And then we go round our loop. So the RTC will wake us up. We will do our measurement of the luminance and the temperature. We'll display that result on the LCD and then send the RF transmission to the monitoring station, and then we drop straight back into stop mode. So you can see here, we do our configuration, then we wait again, take the reading where we run, which is the green line, and then we go back into stop, and we'll get a nice balanced current consumption. So while we're in stop 2, we're consuming about 12 microamps. Average, we're consuming about 48 microamps. But when we're doing the measurement and the updating the LCD and the RF transmission, we're awake for about 5 milliseconds. So we can see the system do things, and you can see that the capacitor is providing us with the charge. So what we do when we're in the stop 2 mode, so we're charging the capacitor. So all these pins are high input impedance, so we charge the capacitor up. When we come to take the measurement, we select the PA0 to be open drain output low. So we get the direct feed into the PA0, where we can read the actual measurement through ADC 1 pin. So we actually take the reading of the lux level. And at this point, the capacitor is supplying the STM32U0 with its power to do that reading. So if I now show you this in action, so I've got a small video.
Okay, so this is the demo. I am located inside the ST building with standard ambient light. Right here you can see the photovoltaic panel from our partner Dracula technology. It's connected to the STM32U0 discovery kit, and on top of it you have the RF daughter board. And here is the 100 microfarad capacitor charged by the photovoltaic panel. So as explained, the U0 wakes up from stop 2 every second to run at 16 MHz and measures the temperature and the light intensity thanks to its built-in ADC. And then the measurements are sent over the RF to the remote receiver that is located here. So you see that you have two curves, one in purple, which is the light intensity, and the dark blue is the temperature. And if I play with the light, you will see that the intensity goes down when I cover the photovoltaic panel, and it goes up again if I remove my hand. So as you can see, this illustrates nicely the capabilities of STM32U0, which is an ultra-low power STM32 microcontroller.